And I know that federation is a big topic that we had in V2, and people have kind of been wondering about how it's going to change in V3 with everything going forward in DDN. So I'm sure a lot of excited people to hear about ways of federating with GraphQL and Hasura. So I'll turn it over to you.
Cool. All right, I'm going to jump right into it. So I think with federation, the trick is that at the end of the day, consumers want a single rock solid API. They don't really want to learn a new API for every data source or every service. And at the same time, you have a bunch of teams that own different parts of the domain. And they're sort of responsible for getting this data to the API. So how do we get both of these at the same time? How do we get a single, consistent, cohesive whole API, while at the same time making sure that teams can continue to iterate on their own domains? And GraphQL, in fact, was created to solve this problem. So we hit questions like, hey, who owns the federation bit? How do we coordinate changes across teams? Who handles things like failures and rollbacks? And some solutions, well, they might want you to do this, but this is not fun. So some solution might say, hey, every team has to maintain their own GraphQL server, which is tedious by itself. And then have some sort of solution where these GraphQL APIs are sort of smushed together. And then you get a final API. And this sort of solution doesn't work well for a few reasons. One is that as an owner of a particular subgraph over here, as an owner of one of these GraphQL servers, I have to worry about whether names I'm using, whether types I'm using actually conflict with any other team. And if you have a bunch of teams doing this, now I have to worry about a lot of conflicts. And also at the router or gateway layer, composition isn't really a good story. And we'll see some examples later, but and the person doing this composition now has to be aware of the entire API service of all of these GraphQL servers across all of these teams. So Hasura takes what I believe to be a more thoughtful approach when it comes to this. And this entire class of issues, it doesn't happen. This is in fact probably, Hasura probably has a better model when it comes to this. So this is sort of our goal, that every team that owns a portion of the domain, which is a subgraph, can do independent SDLC right from development to testing, like iterating on their API, iterating on their portion of the domain. And when they're done, they can take it and they can deploy by themselves. But all of this happens in the context of the supergraph API. So how do we make this happen is the question. Well, we've seen what a supergraph looks like. So this is a model of the supergraph. So you see that there are different models and they're all connected by relationships. And so we have metadata that defines this supergraph. And what we can do is we can say that we're going to split this metadata into different subgraphs. And each team owns one of these subgraphs. So each team owns a portion of the domain. Now, the key thing here, which we're going to come back to again and again, which users of Hasura know, is that these things define models and relationships instead of thinking in terms of GraphQL fields and resolvers. And this turns out to be the right level of abstraction when you want to do federation. So the subgraphs here are proper graphs. They're not GraphQL servers. When you put subgraphs together, you get a big graph, which is a supergraph. With a single repository that contains the whole supergraph, you can just take all your subgraph metadata and create your supergraph build. But then a team in a federation context, a team A, let's say, that owns the subgraph A, they can split off their metadata into only that subgraph's metadata into a different repository. And what they can do now is they can create a subgraph build, which is based on only the metadata for that subgraph. And this subgraph build doesn't actually serve an API, but it is a representation of the metadata. Just like supergraph builds, it's immutable, and it has this unique ID. And then what we can do is team A can go off and they can create their own subgraph builds for their subgraph. Team B can do this for subgraph B. And then when team A wants to sort of test their API, they can take their own subgraph build and they can pull subgraph builds from other teams, and they can build supergraphs, which means they can now test their own subgraph in the supergraph context. And then they can continue to iterate on this. They can continue to create new subgraph builds, and then sort of continue to create new subgraph builds based on that and iterate on it. And then once they're done, and they say, hey, this is the subgraph build that I want, they can take that same subgraph build and they can deploy it to the project URL, which is again just composed of different subgraph builds. So, all right, this is cool. But why is it a good story? Well, here's why. When we're actually composing subgraphs, we get a bigger graph. So the model we're thinking of is actually taking models, relationships, and sort of putting them together. So this is a model based on composition of graphs. It doesn't want to couple different GraphQL APIs. And this is what makes it a completely, a far better model. So let's look at some ways that sort of benefits us. So whenever we build one of these supergraph builds, right, what the build time is actually doing is it's validating all of these models and relationships in the complete supergraph context. So even if you have relationships that are spanning different subgraphs, they're all validated correctly. Also, because the whole supergraph is validated in one time at build time, you're immediately notified of any problems with GraphQL, namespace types, field name, these kind of conflicts, and you can sort of resolve them at that point. Again, this is possible because we're dealing with models and relationships as our fundamental sort of modeling unit. Let's see. Composition. The story for composition is far better than other solutions allow. So here's an example. Let's say you have different subgraphs. This is an e-commerce application, and one team owns the user model, a different team owns the reviews model, and a different team owns the purchase model. So just with these models and relationships set up, you can do things like get me all the users who have a certain number of purchases, but then sort them by the number of reviews they have in descending order. And what this is doing is a bunch of cool things. So it's not just joining based on these relationships, but it's also aggregating across based on these relationships, and it's also filtering based on these relationships. And so composition works exactly the same. This is as good as having different tables in a Postgres database, and that sort of flexibility that you get, but across all your subgraphs and across all your data sources. So you can join, filter, and aggregate across these relationships. Because at the end of the day, the engine actually just runs the supergraph. So if you look at the engine as sort of this query planner, it's sort of optimizing across all these models, across all the subgraphs and data sources. Let's see, performance. Now, because the engine is actually running the supergraph build as a whole, and not really worrying about, there's no extra hop to get to a subgraph, which means performance is automatically that much better. Also, because the engine sees the entire supergraph at one shot, we can do performance optimizations that other people simply cannot. Like we can begin to have much better query plans, or we can begin to parallelly fetch data to actually satisfy that query. Okay, so let's say as a consumer of the API, you found a bug or you found a performance issue. What do you do? Well, with Hasura, because the entire thing is based on models again, because the supergraph modeling, you can come back to the Explorer and you can actually see different models, which data source they belong to and which subgraph they belong to. For example, if I click on products, it shows me, okay, so this is part of the experience subgraph and database one, which means as a consumer, there's a great degree of transparency, and I can immediately go and talk to the right team. And the granularity is down to the database. So this is cool. Let's see. Query plans and tracing work across the whole supergraph. So I think when it comes down to it, yes, and we're building more tools as well, like schema registry and schema diff. The build time validations is already going to take care of a whole class of problems. But you can also do checks at the schema level, the GraphQL schema level as well. So I think federation is an interesting segue for today. Because is GraphQL dead? Well, clearly not, because GraphQL works phenomenally well, I think. But at the same time, the cool thing with Hasura is you're modeling your data domain. And this is one of the things I love about Hasura. Because when you're modeling your domain, when you're thinking about things in terms of the data models, in terms of the relationships between them, you're not really worrying about the tedious details of building out things like GraphQL servers or an API server or fields and resolvers. And that sort of repetitive stuff is taken care of for you at a in a way that's far more performant and expressive than what you'd be able to handle. So hey, your supergraph can serve GraphQL today, but tomorrow maybe it serves gRPC. Maybe that same supergraph could serve SQL. Maybe it could serve REST. And that's cool. And now that you can sort of bring all your data to your supergraph with and parallelize that effort across all your different data domains with different teams, what cool things can you do with it is probably the next question. So you can read more about this at supergraph.io. That gets a lot of the details about supergraph architecture for federated data access layers. So please do check that out. And all right, we'll be rolling this out over the next few weeks. So do watch out for that and let us know what you think.